Keeping up with our motto, let learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students! Today, we are going to continue with Class 9 Science, Chapter number 11, Reflection of Light. Topics that I am going to cover during this session are two types of spherical mirrors, that is concave mirror and convex mirror. As shown in this picture, you must have seen the mirrors displayed in the laughing chamber in a fair. Your face and body appears to be distorted in these mirrors. Why does this happen? These mirrors are different from the mirrors that we have at home. They are curved. The images formed by the curved mirrors are different from those formed by the plain mirrors. Because of this, we do not see the familiar images in these mirrors. These are called spherical mirrors. The rear view mirrors in cars, which enable the drivers to see the vehicles coming from behind, are also curved mirrors. Different type of curved or the spherical mirrors are shown here in this picture. Let us understand the creation of spherical mirrors. Consider this circle as the surface of a rubber ball. If we cut this rubber ball along the two dotted lines shown over here, then we get two different surfaces, one shown by the orange curve and other shown by the blue curve. Generally, spherical mirrors are the part of hollow glass sphere like the part A and B shown in the figure. The inner and the outer surface of this part is coated with a shiny substance to produce a spherical mirror. And the reflection of light takes place either from its outer or the inner surface. Thus, there are two types of spherical mirrors as described over here. One is the concave mirror and other is the convex mirror. Now, let us understand in detail that which mirror and why this mirror is a concave mirror and why this mirror is a convex mirror. As seen in the previous slide, if the hollow sphere is cut along the two different lines, then we get two types of mirror, concave mirror and convex mirror. If a silver coating for the protection is provided on the outer side with the help of a paint, then the reflection of the light takes place from the inner surface of the spherical mirror, then it is called a concave mirror. Whereas if the outer surface of the spherical mirror is the reflecting surface, as shown over here in the picture B, then the mirror is a convex mirror. You can see over here the inner side is coated with a silver coating to provide protection. So, these are the two types of mirror, concave mirror and convex mirror. Let us understand few terms that are related to spherical mirror. First one is pole. The center of the mirror surface over here is called the pole. It is indicated by P in this picture. Second is center of curvature. You can see over here it is indicated by capital C. The center of the sphere of which the mirror is the part. Over here you can see the mirror is the part of this sphere. So the center of the sphere is called the center of curvature. Next is radius of curvature. The radius of the sphere of which the mirror is the part. So as we know, this is the center of the sphere. So radius will be half this along the line CP. So CP indicates the radius of curvature. Next is straight line passing through the pole and the center of the curvature is called the principal axis. It is indicated by the line XY in this picture. Next is principal focus. Incident rays which are parallel to the principal axis of the concave mirror after reflection from the mirror meet at a particular point in the front of the mirror on the principal axis itself. This point F is called the principal focus of the concave mirror. In case of convex mirror, the incident rays parallel to the principal axis after reflection, they appear to come from the particular point behind the mirror lying along the principal axis. This point F is the principal focus in case of convex mirror. Next is focal length. The distance shown by the small f between the pole and the principal focus of the mirror is called focal length. Over here you can see the distance indicated by the small f is the focal length of the mirror. This distance is half the radius of the curvature of the mirror. Let us understand some basic rules for drawing a ray diagram. Rule number 1. Concave mirror and convex mirror are shown over here in the picture. If an incident ray is parallel to the principal axis, then the reflected ray passes through the principal focus. You can see over here, this is the incident ray. This is parallel to the principal axis. So, when it is hitting the concave mirror, it is reflecting back and it is passing through the point F, that is nothing but the principal focus. In case of convex mirror, you can see over here the incident ray which is parallel to the principal axis is getting reflected and it appears to be coming from a point behind the mirror, that is the point F, principal focus. So this is rule number 1. Rule number 2. If an incident ray passes through the principal focus of the mirror, then the reflected ray is parallel to the principal axis. This is the incident ray passing through the principal focus and the reflected ray is parallel to the principal axis. Same is the case in convex mirror. This is the incident ray. It appears to be passing from the focal point and you can see the reflected ray is parallel to the principal axis. Rule number 3. If an incident ray passes through the center of curvature, as shown over here, this is the center of curvature. When the incident ray passes through the center of curvature, the reflected ray traces the same path back. In case of convex mirror also, you can see this is the incident ray. It appears to be passing through the center of curvature. So the reflected ray traces the same path back. There is one more rule, that is rule number 4, which is not mentioned in your textbook. The ray that is incidented at the pole is reflected back, making the same angle with the principal axis. Over here you can see this is the incident ray and this is the reflected ray. The angle formed by the incident ray and the reflected ray with the principal axis is equal, both in concave and convex mirror. Let us understand the images that are formed by a concave mirror. As shown in the picture, if you put a candle in front of a concave mirror, then you can see the magnified image of the candle. Let us understand this with the help of its ray diagram. As shown over here, this is the principal axis, this is the concave mirror, and the small arrow, blue arrow, indicates the object which is placed in front of the mirror. behind the mirror, and it is also virtual erect because the reflected ray are not meeting at a single point. So the image is virtual and it is also forming behind the mirror. So it is virtual, it is also erect, as well as it is magnified. The size of the image is bigger as compared to the object. Over here, the object is kept between the pole and the principal focus. If the position of the object changes, then the image also changes. Let us see in the second example. Over here, the object is placed between the principal focus and center of curvature. In this case, you can see the incident ray and the reflected ray. If the incident ray is parallel, it will pass through the principal focus as per the rules of ray diagram, as well as if the incident ray is passing through the principal focus, then the reflected ray will be parallel to the principal axis. And if it is passing through the center of curvature, it will be reflected back along the same path. So over here you can see the image that is formed is beyond the center of curvature. It is real because it is formed on the same side of the mirror. It is also inverted as well as magnified. So the type of the image that is formed by a concave mirror depend upon the position of the object where it is located. You can see in this table the position of the object are different in different cases, and so is the position of image and the nature of image as well. If the object is at infinity, then the image will be formed at the focus and it will be real, inverted and almost diminished. If the object is beyond C, you can see over here, if the object is beyond C, then the image that is formed is between the C and F and it is real, inverted and diminished. If the object is located at the center of curvature, then the image is also at the center of curvature. It is real, inverted and of the same size as that of the object. If the object is between the principal focus and center of curvature, we have already seen this. The position of the image will be beyond C, it will be real, inverted and enlarged. If the object is placed at F, then the image which will be formed, it will be at infinity. It will be real, inverted and highly enlarged. If the object is placed between F and P, then the image of the object is formed behind the mirror. It is virtual, enlarged and erect image. Images formed by a convex mirror. The nature of the image formed by a convex mirror does not depend on the distance of the object from the mirror. These images are always smaller than the object, behind the mirror, virtual and erect. As shown over here in this picture, when object is placed anywhere between the pole and the infinity, then the image that is formed is behind the mirror, that is virtual, it is also erect and it is smaller than the object. You can see over here, this is the incident ray which is parallel to the principal axis. So the reflected ray appears to be along the focal point. And if the incident ray is passing through the center of curvature, then it is reflected back along the same path. This is the ray diagram for the same. So this is all about today's session. Thank you so much.